Okay, guys, as a reminder, every lesson, your learning goals are at the start of each lesson. We're not re-putting them anywhere in the room, just so you can know where they're at. Last class, we did the powers and exponents to write the prime factorization of a number. Determine greatest common factor, two whole numbers less than or equal to 100. We actually didn't do that, so that's going to be where we're going to start today. Rewriting the sum of two whole numbers with the common factor using distributive property. We did some of that, but we'll do more of that today. We're going to show you how to put these two things together. And then determine the LCM of two whole numbers. So today we're really going to focus in on this whole GCF LCM piece. Okay, go ahead and go to page 16. Page 16. On this page, we didn't do the getting started, so you can ignore that piece. But it's talking about common factors. One way to determine common factors is to use our prime factorization. So start by writing each number as a product of its prime factors. Last class we finished with that using our factor trees, right? I'm going to show you guys now an easier way to do prime factorization. And it comes down to using your 4 key numbers. Who remembers what our 4 key numbers are? Ben?
2, 3, 5.
Awesome, you nailed all 4 of them. 2, 3, 5, and 7. So watch how easy this can be. If I take a number, say 56, to find the prime factorization, I'm just going to use my 4 key numbers. So I'm going to say, can I divide 56 by 2? Yes, so I do it. So 2 goes into 5 twice, with 1 left over, gives me 16, goes into 16 8 times. Can I divide 28 by 2? Yep, so I do it. 2 gives me 14. Can I divide 14 by 2? Yep, so I do it. 2 and 7. 7 is one of my 4 key numbers, so I'm done. You now have the prime factorization of 56. 2 times 2 times 7. So rather than having to do that whole tree and figure out all the different factors, the cake will actually line them all up for you. So let's do the other one. 42. We go through that same process. Can I divide 42 by 2? Yeah, so I do it. 2 gives me 21. Can I divide 21 by 2? No, not evenly. Can I divide it by 3? Yeah, so I do it. Divides by 3 gives me a 7. 7 is one of my 4 key numbers. I'm done. So all I have to do now to get my prime factorization is rewrite it. 2 times 2 times 2 times 7. 2 times 3 times 7. Prime factorization pretty easy? It is if you focus on your 4 key numbers. Yes, anything I write on the board, you should write in your modules. Sorry, we're still new. I forget that I still have to remind you of that. But yes, anything I put on the board or Ms. McSham puts on the board, you should put in your modules. Okay, now the way they want us to teach us to you is we take those prime factors and we put them into a table to be able to compare. So you'll notice, to organize the prime factors in a table, I only list shared factors in the same column. So for 56, it's 2 times 2 times 2 times 7. For 42, it's 2 times 3 times 7. Notice that because they both have a 2, I put a 2 in both of them, right? Does 42 have a second 2 as a prime factor? No, but 56 does, so I need to leave that one blank. Same with the third 2 that we don't share. Does 56 have 3 as a factor? No, so I have to leave that one blank. But then they both have a 7. Make sense? Does everybody understand how the table is organized? Okay, we again are using good mathematical practice. We start at the smallest number, build to the largest number. You should always do that when you're listing your prime factorizations. So what you're going to figure out, how do I know that 14 is a common factor of 56 and 42? How would you know that? What do they both have? They both have a 2. They both have a 7. But then what's 2 times 7? 14. So there are the common factors for those 2 numbers. So I take any common prime number. If they have more than 1, I will multiply all of those to figure out the largest common factor. Keegan? That would be best, yes. Good job. Okay? So, how do we know it? Because 2 times 7 gives you 14. Now, secondly, why is there a space between 2 and 7 in the top row? In other words, why do we have that space in there? We kind of already said it. Let's see who paid attention. Ben?
Because going from one number to a different number.
I didn't put a space between 3 and 7. Claire? Okay, so you actually said it. I'm not sure if you understand that you said it, but it comes down to the fact there isn't a 3 as a factor for 56, but there is for 42, so I have to leave that one blank. Okay, so why is it blank? 3 is a factor of 42, but not 56. So we leave the blank because the factors are in order. Make sense? Give everybody a second to catch up on writing that. Okay, let's go ahead and turn to the next page. We're on page 17. Okay, now we're going to change numbers. We're going to try this again using a different set of numbers. So consider the numbers 54 and 84. Create a table of prime factors. So that's what we need to do. So to create the table, we need to know what the prime factors are. So do you guys want to do a factor tree, or would you rather do the cake? Raise your hand if you'd rather do a factor tree. Raise your hand if you'd rather do the cake. Well, I'm going to have fun on this one. Okay, all of you raised your hand to do the factor tree. Please get started. I'm going to give you a 30-second head start. Those of you that want to do the cake, you can wait for me because that's what I'm going to do. There's 30 seconds. Now we're going to start with the cake. So 54, can I divide by 2? Yep, so I do it. 27, can I divide by 2? Nope, 3, yes. 3 gives me a 9. Can I divide that by 3? Yes. There's my factors for 54. What about 84? Can I divide that by 2? Yes. Gives me 42. Can I divide that by 2? Yes. Gives me 21. Can I divide that by 2? No, by 3. Yes. Okay, I'm done with my factors. How are you guys doing on the factor tree? Almost done. I gave you a 30-second head start. We're already done. Okay. I guess if you really like your factor trees, go for it. But I think I'm trying to show you a much easier, simpler way to do this. Okay, once you have your prime factorization, which technically I don't, because I need to rewrite it, 2 times 3 times 3 times 3, and 2 times 2 times 3 times 7. That's actually your prime factorizations. The cake just gives you all the numbers you need to put in there. Now we can build our table. So we're going to create our table of prime factors for 54 and 84. Do they both have a 2? Yes, I'll put a 2 for both. Do they both have 2 2s?
No.
Do either of them have a second 2?
No.
Yes, the 84 does. So I'll put another 2 for 84. I leave the 54 blank, right? Do they both have a 3? Yes, I'll put a 3 for both. Do they both have 2 3s? No, 84 only has 1. Do either of them have 2 3s? Yes, 54, so I need to add another 3 to 54. Do either of them have a third 3? Yes. Do they both have a third 3? Obviously not, because one didn't even have 2, so I'll add the 3. Do they both have 7s? No. Only the 84 has a 7. So we have a lot of blanks in our chart, but we now have all of their factors listed, and we can now find our common factors, correct? So which ones do they have in common?
3 and 2.
Good. So they both have a 2. They both have a 3. If they both have a 2 and a 3, what's the other one that they would have? Ben? 6. Because 2 times 3 is 6. So, common factors are 2, 3, and 6. Of the common factors, which is the largest? So there's our question. Who was that? Tiana? Good. Make sure you're raising your hand, though. So the largest factor, or the largest common factor, is 6. Does everybody understand where that came from? Okay? Okay, who wants to have their mind blown?
No.
I'm going to show you guys something that is so easy to find your GCF. You're going to be like, why did you just spend 10 minutes going over that one problem? Watch how this can work, guys. Anytime I want to find the GCF or LCM of 2 numbers, for example, 54 and 84, I just write them side by side, 54, 84. I put a division bar over both. And here's where your 4 key numbers become your best friends. I just check all 4 of my numbers and say, does it go into both? Can I divide both 54 and 84 by 2? Yes. So I write a 2 here, and I actually do it. So 2 goes into 54, 27 times, goes into 84, 42 times. Then I check again. Can I divide them both by 2? Can I divide them both by 3? Yes. For any of you that were wondering, what's 4 plus 2? 6. I can divide that by 3, so I know I can divide it by 3. What's 2 plus 7? 9. I can divide that by 3, so I know I can divide it by 3. So yes, I can divide both those by 3. Then you just got to figure out what it is. In this case, it's 9 and 14. Then I check again. 9 and 14. Can I divide them both by 2? By 3? By 5? By 7? If I've said no 4 times, that means I'm done. My GCF, my greatest common factor, is on the left. So I multiply the numbers on the left. What's 2 times 3? 6. So you can do all of this, or you can do this. It wasn't for nothing. It's to help you understand there are multiple ways to find the GCF, and there's actually other ways. We'll do another one in a little bit, but I wanted to show you guys how easy this can be as long as you pay attention to your 4 key numbers. Okay? Now, we do need our highlighters. We have another definition. The greatest common factor is the largest number, largest factor 2 or more numbers have in common. We actually have a second definition on this page. It's actually really important. Our second definition is over here on the side notes, and that is the term relatively prime. Numbers are considered to be relatively prime when the only common factor they share is 1. So in other words, if their GCF is 1, they are considered to be relatively prime. That's going to come in just a little bit when we start talking about multiples. Does everybody understand what we're doing so far? Okay? So, we're going to rewrite each sum using the GCF and the distributive property. So the first part in this is finding the GCF. Okay? So let's go through the cake method again to help everybody understand how this works. So 56 and 42 we haven't done yet. We just did the other one. So let's do that. 56, 42. Can I divide those both by 2? Yeah, so I do it. Put a 2 here. Gives me 28 and 21. Can I divide both those by 2? Nope, that's an odd number. Can I divide them both by 3? 2 plus 8 is 10. I can't divide that by 3. Can I divide them both by 7? Yes. So now I'm going to add another layer to my cake with 7. Gives me a 4 and a 3. Can I divide those both by 2?
No.
By 3? So I'm done. So what is my GCF? 14, because I multiply my numbers here. Okay, so my GCF is 14. Here's how we turn this into distributive property. So I know the greatest common factor is 14, right? So that goes on my outside. You want to see something really awesome about the cake method now too? Guess what goes on the inside? 4 plus 3. It actually tells you what the other pieces are for the distributive property. It's your top line, just added together. Let's check it. Let's use a distributive property, see if this actually works. So distributive property means I'm going to multiply each of these by 14, right? 14 times 4 gives me 56, plus 14 times 3 gives me 42. Did I get back to where I started? Yes.
So to get the 14, how we got it from the 7 and the 2?
Correct. We have to multiply the numbers on the side. So you're going to multiply any numbers on the side to find your GCF. Great question, Jamila. Okay, 54 and 84 we just did, so I don't have to redo that. So what did we say the GCF was?
6.
This is 54 and 84 here, guys. We did it in the problem above. So my GCF was 6. My top line was 9 plus 14. So I can now use it very easily, rewrite it using distributive property. 6 is that common factor times the quantity 9 plus 14. Let's verify it. Use the distributive property. 6 times 9 is 54 plus 6 times 14. 6 times 4 is 24. Carry the 2, gives me an 8. 84. We got right back where we started. Did we do it correctly? Was this easy?
Yes, it's so easy.
Can you see how your distributive property works with the GCF and LCM? Can you see how the cake method puts all this together for you really easily? Okay? Good. So hopefully I've got some converts. Let's go to the next page. Now we're going to look at the multiples. Multiples are different than factors. Okay? So, again, pull out your highlighters. We have another definition over here. Your multiples are the product of a given whole number and another whole number. So in other words, multiple is saying I'm multiplying numbers and seeing what they get when they get bigger, which is going to come in again a little bit later when we start comparing the GCFs and LCMs. So understand, multiple is I multiply the number out. It's what I get as I multiply a number. So we're going to start with another grid example to help try to get this into your minds as to what we're doing, okay? One way to think about an area model is analyze the collection of columns. Which way does a column go? Good job, Jamila. Up and down. So I'm saying up and down. So if I count up and down, that first column, how many total blocks would I have? 6. So if I put a 6 down there, that's saying keeping track of how many I have. What if I add in a second column of 6? Now what am I up to? How many blocks? 12. So I can put that down there, right? And we can do that all the way across our model, can't we? Keep track of our boxes. So we have 12, then we'd have 18, 24, 30, 36, 42, 48. That makes sense for everybody. Okay? Now, we could also analyze the rows. Which way do rows go? Sideways. That's left to right. So now, if I counted across, how many blocks would I have in my first row? 8. So then if I add in my second row, how many am I up to? 16. Then my third row, 24, 32, 40, 48. So really what we've done is we just listed the first 6 multiples of 8 and the first 8 multiples of 6. Once we have our list made, we can now take a look and start analyzing it. So we basically did all that. We listed the first 8 multiples of 6, and we listed the first 6 multiples of 8. I do want to add this one in, because we're going to talk about this one in a little bit. It's the commutative property of multiplication. Again, pull out your highlighters or marking pens. The commutative property of multiplication states that for any numbers a and b, the product a times b is equal to the product b times a. Or to give you an example, what's 2 times 6? 12. What's 6 times 2? 12. Did it matter what order I did it in? No, that's what the commutative property says. If I'm multiplying, I don't care what order you go, you're going to get the same answer. Okay? So we will actually use that concept later on to help make our math a little bit easier. Everybody good so far? Okay? So for me, I'm turning the page. You guys are just looking at the next page. We have another definition in here. We have now what we call the least common multiple. So the least common multiple is the smallest multiple other than 0 that 2 or more numbers have in common. It is possible to find the LCM of multiple numbers. Normally, especially for us, we're going to focus on 2. We will do some sets of 3, but understand that that's what it is. So as I looked at my list across the top and bottom on the 6 and the 8, what did you see as common multiples? You have the whole list there, right? Alina?
24 and 48.
Good. You had 2 common multiples. They both had a 24. They both had a 48, correct? So which one is the least of those? 24. So my LCM is 24. Is everybody okay with that? Okay. Let's go ahead and do this next one as well. As demonstrated by the rectangular array, for any 2 whole numbers a and b, a common multiple is a times b. However, this number may not be the least common multiple of a and b. Okay? So let's take a look and see. Determine the least common multiple of 6 and 9. So there's our question. So our first task, list the first 9 multiples of 6. So in other words, we're going to start at 6 and go out 9 multiples. So if I start at 6, what would be next? 12, then 18, 24, 36, 42, 48, 54. Then we're going to list the first 6 multiples of 9. So now we're going to start with 9 as our base number. So starting at 9, what comes next? 18, 27, 36, 45, 54. Bless you. There's Kleenexes on the student desk if you need one. Okay, so what is the least common multiple of 6 and 9? Raise your hand when you see it. I'm going to wait till I see more hands. Everybody needs to find it. What's our least common multiple between 6 and 9? Raise your hand when you've got it. Okay, where would be my best bet? Marlo, what did you get for least common multiple? 18. Did everybody get 18? Be honest.
Yeah.
So nobody saw 36? Nobody saw 54? Oh, I did, didn't I? Gosh, it's almost like that might have been planned. The problem is you found it too quick. I was going to point it out in a minute. So, guys, here's the problem. I could list all of these multiples, and if I missed one, like my 30 that I forgot to put in there, that just happened to be a common one, I could have missed the entire problem, couldn't I? If I focused and I ended my list at 54 and I said, oh, they're both 54, and I put that down as LCM, would I have been correct? No. What if I was smart and I saw the 36, but I didn't see the 18? Would I have gotten the correct answer? So we've already found 3 ways that doing this list can make it very easy for us to mess up LCM, haven't we? I can forget a number, I can not see which one is the smallest, or I might just go with the biggest. You guys want to see an easier way to do this?
Yes, please.
Okay, watch this. Instead of doing all of this, I can come back to my friend the cake. 6 and 9. Can I divide those both by 2? By 3?
Yeah.
So I do it. 3 gives me a 2 and a 3. Those are 2 of my 4 key numbers, so I know I'm done. So guess what? Not only do we know the GCF now, what's my GCF? 3. I only got one number on the left, guys. So my GCF is always on the left. So GCF is 3. But I also now know my LCM. What's 3 times 2?
6.
Times 3?
18.
So in one easy step, I have now identified both the GCF and the LCM. Okay? What about 7 and 8? Let's try the same thing. And rather than list them all out, let's just do cake. 7, 8. Can I divide both those by 2?
No.
Both of them by 3? Both by 5? Both by 7?
No.
Uh-oh, I just went through all my numbers. What do I put? So what do they have in common if they don't have 2, 3, 5, or 7? Ricardo? Awesome! They have a 1 in common. We actually just gave you that definition, didn't we? So how do we refer to these two? If their GCF is 1, what's the math term for it? Mason? Nope, that would just say, whether I do 1 times 8 times 7 or 8 times 1 times 7 or 8 times 7 times 1, I'd get the same answer, which is going to tell me what my LCM is. Isabella? They are relatively prime. And by our definition, if they are relatively prime, how do I find the GCF? You do. The definition of relatively prime tells you how to find the GCF. Ricardo? If they are relatively prime, I just multiply the numbers. What's 7 times 8? 56. So my GCF is 1. If they are relatively prime, my LCM is going to be the numbers multiplied by each other, 56. So my LCM in this case is 56. Is everybody tracking so far? Okay? So, rather than do this part, because we've already done this, I want you guys to add a note in here. And I've got to give Miss McShann credit on this. She came up with this little mnemonic to help you. But to use the cake method, remember what is what? Remember, GCF is on the left. Multiply the numbers. LCM is all of them. And again, we're multiplying the numbers. So what the cake method does is it breaks out your prime factors from both numbers so that you can understand what they have in common and how to put them all together to find the LCM. Your GCF, whatever numbers are on the left, I'm going to multiply all of them. Sometimes you're going to find cakes that are 3 or 4 levels. Doesn't matter. You're going to multiply them all. The LCM is everything on the outside gets multiplied. But remember, back to Mason's point, commutative property of multiplication means I can multiply them in any order that makes the math easier for you. So we'll show you guys a couple examples of that as we continue and work a few more problems. Any questions on anything we have covered so far? Okay. And I do want to point out, we have showed you multiple ways. If you just really don't like the cake, if you want to do factor trees and build the prime tables and all that, more power to you. But I'll be honest, one of the biggest issues is once you've built that table, remembering, am I pulling the ones that are the same for GCF, or am I pulling the biggest of all the different ones to get the LCM? So to me, it gets way more confusing. If you guys will just focus on your 4 key numbers, 2, 3, 5, and 7, and do the cake, it lays it all out for you. Okay, let's go ahead and go to page 20. So if I wanted to find the LCM of 56 and 42 without drawing the area models or another way, again, we could break them down. Okay? So to do 56 and find its prime factors, do I have anybody that still wants to do a factor tree? I'm down to 2. 1. You want to do a factor tree for it? I missed it. What do you say? Then you can do factor tree. I'm not going to stop you. Personally, I'm going to do cake. 56, I can divide by 2. 28, divide by 2. 14, divide by 2. Gives me a 7. Good luck getting that fast on a factor tree. Okay? 56. Oh, I did the 56. 42, divide by 2 gives me 21. Divide by 3 gives me a 7. So 2 times 2 times 2 times 7. 2 times 3 times 7. You should be able to factor numbers that quickly if you'll use the cake and focus on your 4 key numbers. Remember, if my top number is not divisible by 2, 3, 5, or 7, that means it's a prime number, which means it is part of your prime factorization. So far, we've been giving you easy numbers that didn't go to any of the other bigger primes. Okay? So, in order to find the LCM, we're going to put the 2 together. So they built the table. Here's how you do it if you're using the table to find LCM. To find LCM using the table, I got to take all of the largest numbers. So this one has 3 2s. This one has a 3. They both have a 7. So I'm going to multiply all of those numbers out in order to find the LCM. In this case, 168. If I used my cake method with both numbers, watch how easy this becomes. 56, 42. Can I divide both of those by 2? Yep. 2 gives me a 28 and a 21. Can I divide both those by 2? By 3? By 5? By 7? Yes. So I'll do one more layer on my cake. Gives me a 7, a 4, and a 3. Okay? 4 and 3, I know 3 is one of my prime number or key numbers. Won't go into 4, so I'm done. So now's where you've got a lot of different options because of the commutative property of multiplication. So I could do 2 times 7 times 4 times 3. I could do 4 times 3 times 2 times 7. However is going to make it easiest for you. For me personally, I would go 2 times 4 is 8. 8 times 7 is 56. And then I just do 56 times 3. Would give me 18,168. Which is what they told us it was. Is it making sense so far? What's not, Riker? And honestly, I appreciate you being honest, because if it's not making sense, we've got to work through till it does.
Why would we do 3 times 4?
Because it's the greatest number that any one has. But it's also why I don't like using the table method. Because if I use the table method, you've got to be able to figure all that out, because it's different. The rules are different in the table for what I'm pulling out for GCF versus what I'm pulling out for LCM. That's why I hate this method, I'll be honest. I would never do this. And I wouldn't teach it, but it's in our curriculum, so I need to teach it. But I would use the cake 100% of the time, because it's going to lay it all out for you every time, and very easily, unless you make a silly math error, because you're doing single-digit division. It's 2, 3, 5, and 7. So you should be able to do that one quickly and very efficiently. Okay, I'm going to give you guys a chance to practice. Here's your 2 numbers, 12 and 10. I want you to find me both the GCF and the LCM for that set of numbers. I'll give you guys about 3 minutes. Go ahead and go. Okay, so looking at this one. Again, cake is going to make this easy. I start with my 12 and 10. Can I divide both of them by 2? Yeah, so I do it. 2, 6, and 5. Can I divide both those by 2? By 3? By 5? Literally, you should be going through the list that fast, guys. So my GCF is on the left. My GCF is what? 2. My LCM is all of them. So here's Mason again, where I'm going to use commutative property. I like to look at the numbers and say what's going to be easy. So I see 2 times 5 is 10. 10 times 6 is 60. Would I do the same if I did 2 times 6 is 12. 12 times 5 is 60? Yeah, but for Mr. Moore, I love working with powers of 10, because in math, if I'm multiplying, doing a 10 just means I put a 0 at the end. So look for those things. Commutative property of multiplication says that's okay. I'll get the same answer as long as I don't make a math error, regardless of how I multiply them. Questions on anything we did on that one? Okay, here's your big shot, guys. 3 problems. GCF and LCM for all 3. I'm going to give you guys 5 minutes. What's that? You only need 4?
No.
Oh, we're going to 3? Okay, it sounds like 5 is a good compromise then. We'll go with 5. Okay, if you're using the cake, this is super, super easy, guys. All I need to do, 9, 15. Can I divide them both by 2? No, by 3? Yes, 3 gives me a 3 and a 5. Remember, my GCF is on the left. Whatever is over here, I multiply. In this case, it's just a 3. So GCF is 3. LCM is all of them. So I'm going to multiply everything on the outside. 3 times 3 is 9. 9 times 5. That fast. You should literally be done that quick on these problems, guys. Okay? 9 and 10. Can I divide them both by 2? By 3? By 5? By 7? So what is their common factor?
1.
1. What is the math term we just learned where their GCF is 1?
Relatively prime.
Excellent, Mason. They are relatively primed. So my GCF is 1. My LCM, I still multiply all of them or multiply them together, is 90. Okay? 5 and 9. 5, 9. Can I divide them both by 2? By 3? By 5? By 7? See how easy this can be? GCF is 1. LCM is 45. Should be that easy for you guys. Okay. Now, mostly because I want to show some people that are still struggling on the cake how easy this can be and how nice it sets it up for you. Let's do these 2 numbers really quick. 36 and 24. 36, 24. Can I divide them both by 2?
Yes.
Yes, so I do so. 2 gives me 18 and 12. Can I divide those both by 2? Yes, so I do it. Gives me a 9 and a 6. Can I divide both those by 2? By 3? Yes, so I do it. 3 gives me a 3 and a 2. Those are 2 of my 4 key numbers, so I know I'm done. For my GCF, I'm just multiplying them. 2 times 2 is 4. 4 times 3 is 12. So my GCF is 12. My LCM is all of them. So I know I have 12 on the top, 6 on the side. 12 times 6 gives me. Is that hard? Who said yes? I hope you're kidding. Now, the one other thing I want to do is express it as a product of A times B plus C. Well, guess what? If you're doing the cake, they've already done the work for you. We know our GCF is 12 times the quantity of 3 plus 2. They gave it to us on top. Is using distributive property hard if you've used the cake?
No.
Shouldn't be. They've literally given you every number you need. Questions on any of these? Okay, we're not going to worry about the rest of those numbers. I just wanted to use that as an example. Okay, unfortunately we're out of time, so we need to go to page 25. Go ahead and rip this out. This is your homework. I have a few notes we need to add on our homework. You shouldn't be putting stuff up yet, Ricardo. Okay, note number 1. Is our journal entry optional? No, we must do our journal entry. I will tell you, this is the easiest journal entry you're going to have. Because they gave you a sentence, all you got to do is circle which number is correct. But you do have to explain your choice. So tell me why you chose that one. Part 2, create a factor tree and write the prime factorization. You got 2 options. You can do the factor trees or you can do this single cake. Remember how we did that earlier? Either one's fine, but make sure you write the prime factorization. Okay, number 2 is where we get to our choices. You can do all of this. List all the factors of each of those numbers, then figure them out. Or do cake and find both GCF and LCM. So add that into your notes or come back to the video. Why are you putting stuff away, Riker? Bad choices. Again, if I'm writing it on the board, you should be writing it on your paper. So you have an option here. You can do all of this, or you can just do the cake and find GCF and LCM. Go to page 26, and you have that same choice. You can do all of this, or just do cake. And find GCF and LCM. Okay? Number 4, I do want to change a little bit. Rather than doing this, I want you to find GCF and LCM for all 3 sets. Your method is your choice. Highly recommend the cake. Stretch. This is now it's getting into 3 numbers. We didn't cover that. Cake goes the same way, but after you find 2, you do an extra layer to see if there's any additional common factors with the other numbers that are left. Okay, good luck, guys.